Hi everyone, this is Michelle from GCE Education Hub. Today we'll be going through factor and remainder theorem of polynomial. So let's go! It's a remainder theorem. It's when a polynomial is divided by a linear divisor and gives a remainder of r. Okay, we have this as follows. Alright, now where do we get minus b over a? Essentially what we're going to do is we're going to solve for roots. Something like solving for roots. So we have ax plus b equal to 0, and then we have ax equal to minus b, and therefore x is equal to minus b over a. So this is where our negative b over a is from. Okay, so let's look at example. So we have to find the remainder when this polynomial is divided by x plus 2. So when we want to divide by x plus 2, what is the value we sub in? Don't guess by substituting x equal to 2. So remember, we have to solve for roots. So we have to do x plus 2 equal to 0, which means that x is equal to negative 2. So when the question wants to find the remainder when divided by x plus 2, we simply sub in f negative 2 into the equation. Okay, and by using our calculator, you will see that the remainder is negative 87. Alright, so now let's try to find the remainder when it is divided by 2x minus 3. So the same thing, alright, we have 2x minus 3 equal to 0. And then what we have is x equal to 3 over 2. So we need to sub in 3 over 2 to find our remainder. So likewise, same as the previous question. Alright, we're going to sub in x equal to 3 over 2. And we will get our remainder out, which is 4. Okay, so now we're going to do an example, alright, that makes use of a remainder theorem. So we can see that the expression leaves a remainder of 9 when divided by x minus 1. So what we're going to do is, you need to write down the equation of this. Okay, so remember when we solve x minus 1 equal to 0, x is equal to 1, and it gives a remainder of 9. So it means that when I sub in x equal to 1, okay, my value will be 9. Right, so this is your first statement. And likewise for the second statement, it says that it gives a remainder of negative 27. Right, when divided by x plus 3, which also means that when you sub in f negative 3, you will get negative 27. So what you're going to do now is just sub in the values respectively. Alright, so we have 4, 1 cube. So simplifying the equation, we'll have a plus b equal to 2. So this is your first equation, alright, from the first part. Alright, so we'll do the same for the second equation. So we'll have 4 times negative 3 cubed plus a times negative 3 squared plus b times negative 3 plus 3, so equal to negative 27. Alright, simplifying the equation, we will have 9a minus 3b equal to 78. So you can see that all the values are divisible by 3, so we're just going to divide the whole equation by 3. Alright, and label this as equation 2. So this equation comes from the second equation. Alright, so we're going to do this, we're going to solve this simultaneously by adding equation 1 plus equation 2. Alright, so when we solve, we have 4a equal to 28 and a will be equal to 7. Alright, so now substituting a back into equation 1. Alright, we have 7 plus b equal to 2, and therefore b is equal to negative 5. Alright, so next we're going to go through factor theorem. So factor theorem actually just means that when a polynomial is divided by a linear factor, it doesn't give you any remainder. So you can see that actually our right hand side here, okay, instead of a numerical value, it will just be 0. Right, so we're going to look at an example. So when you say that find the value of k for which x minus 2 is a factor, so it's the same thing. First step, alright, we will let this whole polynomial be equal to fx. Alright, so when we say that x minus 2 is a factor of a polynomial, alright, it means that when I sub in x equal to 2, it will be equal to 0. Alright, so substituting the values inside, we will be able to solve for k. Alright, so using your calculator, you realize that k is actually equal to negative 26. So this is how we apply the factor theorem. Alright, so now we're going to go through an example that make use of both factor theorem and remainder theorem. Alright, so it says that given that fx has a factor of x plus 3, alright, so using the first part, when it has a factor of x plus 3, it means that when I sub in x equal to negative 3, I'll get 0. Right? Likewise, for the second part, it says that it leaves a remainder of negative 28 when divided by x minus 1. So it means that when I sub in x equal to 1, okay, I will get negative 28. So what we're going to do is we're going to sub in the values respectively, okay, and get two equations. So when I sub in the first equation, I will have 9a minus 3b equal to 84. Alright, since all the values are divisible by 3, so we're gonna divide everybody by 3 to get a simpler equation. And this is my first equation. So this equation comes from this. Alright, so we're gonna sub in the second equation. Okay, so what we have is when we simplify, we will get a plus b equal to 0. So this equation comes from the second condition. Alright, so what we're going to do is we're going to solve for equation 1, okay, plus equation 2. Alright, we realize that 4a is equal to 28, a is equal to 7. So substituting this back into equation 2, we'll have 7 plus b equal to 0, and therefore b is negative 7. So this is how we apply factor and remainder theorem in polynomial. If you find the content we are sharing useful, remember to like and subscribe. See you soon. Bye bye.